In the heart of 1977, a new chapter in human exploration began, a moment destined to echo across the stars. That year, NASA launched two extraordinary spacecraft, Voyager 1 and Voyager 2. These robotic pioneers were more than machines. They were ambassadors of Earth, sent forth to explore the unknown edges of our solar system and beyond. Their mission? To journey where no human-made object had ever gone before, and to reveal the secrets of the great cosmic frontier. At the time of their launch, the outer planets, Jupiter, Saturn, Uranus and Neptune, remained cloaked in mystery. No spacecraft had ventured so far, and much of what we knew came from telescopic observation alone. Voyager 1 and 2 were tasked with changing that. Each carried a golden record, inscribed with the sounds, music and greetings of Earth, a time capsule intended for any intelligent life they might encounter. Their journey began with flybys of the giant planets. The Voyagers captured breathtaking images of Jupiter's turbulent storms, the complex ring system of Saturn, the icy beauty of Uranus and the deep blue hues of Neptune. They discovered active volcanoes on Jupiter's moon Io, the possibility of subsurface oceans on Europa, and the stunning hexagonal storm at Saturn's pole. Yet their mission didn't end there. Decades later, Voyager 1 became the first human-made object to cross into interstellar space, leaving behind the heliosphere, the protective bubble created by our sun's solar wind. Now, Voyager travels through the space between stars, still transmitting data back to Earth across a distance of over 14 billion miles. Voyager 1, now over 14 billion miles from Earth, continues to astonish humanity. Not with images this time, but with sound. In 2021, it detected a faint, persistent cosmic hum, an eerie, low-frequency vibration that echoed through the silence of interstellar space. This discovery was not just poetic, it was revolutionary. Recorded using Voyager's plasma wave subsystem, the hum is not static, nor is it an artificial signal. It's a steady oscillation in the plasma density of the interstellar medium, the vast, invisible ocean of charged particles that exists between stars. Scientists describe this hum as the interstellar wind's song, a kind of background radiation from the interactions between dying stars, galactic particles, and the remnants of ancient supernovae. This wasn't the first time Voyager 1 heard something strange. Back in 2012, when it crossed the heliopause, the boundary where the Sun's influence ends, it also captured a burst of plasma waves, indicating its transition into interstellar space. But the 2021 hum was different. It was constant, low-level and ongoing. A faint, ghostly soundtrack that had persisted for nearly 3 years before it was identified in the data. So what does this mean? To scientists, it's a breakthrough. It proves that interstellar space is not a void, but rather a dynamic environment filled with movement, pressure and sound, albeit at frequencies no human ear can detect. The cosmic hum helps researchers map the density and pressure of interstellar plasma, potentially unveiling new physics about the behavior of matter in deep space. To the public, however, the hum evokes something more primal, a sense of connection to the cosmos. For the first time, we're not just seeing space or measuring it, we're hearing it. And that auditory link between Earth and the stars taps into something deeply human, the need to listen, to understand, and to feel part of a greater whole. But the cosmic hum is only one part of Voyager 1's unfolding legacy. In addition to the plasma wave readings, the probe continues to send back data on cosmic rays, magnetic fields, and shock waves from solar outbursts that reach even the edges of our solar bubble. These readings help scientists model the protective barrier around our solar system, essential knowledge for planning future missions beyond Mars and even beyond the Kuiper Belt. And then, of course, there's the possibility, however remote, that Voyager may one day intercept or detect a signal of artificial origin, something that challenges our understanding of life and intelligence in the universe. While the current is believed to be natural, it has nonetheless rekindled discussions about the limits of our knowledge and what else might be out there waiting to be heard. The Voyager missions have never been just about data, they're about presence. Voyager 1, now the farthest human-made object in history, carries with it the golden record, a time capsule of Earth sounds, greetings and music designed for any intelligent life that might find it. Ironically, while we sent out our own audio into the stars, Voyager has now returned the favor, with a song of its own from the vast cosmic sea. In the end, the cosmic hum is not just a phenomenon, it's a reminder. A reminder that space is not silent, that even in the darkest corners of the universe, something stirs, something speaks, and thanks to Voyager 1 we are listening. Yet even at this unimaginable distance, Voyager 1 continues to whisper back to us, transmitting faint signals that traverse the cold, empty void of interstellar space. Each transmission is a miracle of engineering, a testament to the vision of the scientists and engineers who launched this mission over 4 decades ago. What started in 1977 as an ambitious plan to explore the outer planets has now become humanity's first true foray into the space between the stars. As Voyager 1 drifts through the interstellar medium, it no longer feels the warm embrace of our Sun's solar wind. It is beyond the heliopause, where the Sun's influence gives way to the galactic environment. Here it samples the raw, untamed particles that float through the Milky Way. Charged remnants of ancient stars, shockwaves from distant supernovae, and the whispers of cosmic radiation that echo across time and space. What makes Voyager 1's journey even more astonishing is its continued functionality. Designed for a mission that was only supposed to last 5 years, this probe has defied all expectations. Its radioisotope thermoelectric generators still power its instruments, albeit with diminishing strength. Every byte of data it sends is cherished by scientists, representing a glimpse into a region of space that no probe had ever reached before. Its discoveries continue to reshape our understanding of the universe. From detecting plasma waves in the interstellar medium to measuring cosmic ray intensity far beyond the planets, Voyager 1 gives us rare insights into the environment outside our solar bubble. And perhaps, most hauntingly of all, it has captured the sound of the cosmos. The low, steady hum of interstellar space, a phenomenon previously undetected and deeply profound. Meanwhile, its twin, Voyager 2, follows its own path through the cosmos, having taken a slightly different trajectory that allowed it to visit all 4 gas giants, Jupiter, Saturn, Uranus and Neptune, before departing the heliosphere in 2018. The 2 spacecraft now travel alone thousands of miles apart, but forever linked in purpose and destiny. Together they are humanity's ambassadors to the stars. What lies ahead for Voyager 1 is unknown. It will eventually run out of power, perhaps in the next few years, and fall silent, drifting endlessly through the galaxy as a ghost ship of Earth, carrying with it the golden record, a carefully curated time capsule of music, images, and greetings, in 55 languages, meant for any intelligent life that may one day find it. In a way, Voyager 1 is not just a machine, it is a message from one species on one small planet, reaching out to the cosmos with hope, curiosity, and the desire to be known. As we look to the future, to missions like Artemis, Dragonfly, Europa Clipper, and beyond, we remember that it was Voyager that laid the foundation. It dared to venture where nothing had gone before, and through it we dared to ask the most profound of questions. What lies beyond our world? And are we truly alone? Stay with us as we continue to chronicle Voyager's journey and explore the mysteries it unveils. The universe is vast, and our journey is just beginning. Regions of interstellar space. This hum, a persistent, low-frequency vibration, was unlike anything previously recorded. It was not the radio chatter of planets or the static of solar winds. Instead, it was a subtle, continuous resonance emanating from the interstellar medium itself. NASA scientists were intrigued. This phenomenon, now referred to as the interstellar plasma wave hum, provided direct evidence that Voyager 1 had indeed crossed into a new realm of space. The hum was created by oscillations in the ionized gas or plasma that fills the vast space between the stars. This marked the first time humanity had directly heard the natural frequencies of interstellar matter. Unlike the dramatic bursts of plasma activity observed near the Sun, this hum was steady, unwavering, and eerily calm. Its presence suggested that the interstellar environment was far from empty. Rather, it was alive with invisible forces and particles, shaped over billions of years by supernova explosions, stellar winds, and galactic tides. This discovery not only confirmed Voyager 1's entry into interstellar space, but it also opened a new chapter in space science. Scientists could now map the density and behavior of interstellar plasma, something previously relegated to theoretical models. With each passing month, Voyager 1 continued to collect data that offered unprecedented insights into how our solar system interacts with the greater galaxy. Meanwhile, Voyager 2, Voyager 1's tireless sibling, pressed on through the darkness. Its journey past Uranus and Neptune had already yielded groundbreaking discoveries. The tilted magnetic field of Uranus, the supersonic winds of Neptune, and the detection of previously unknown moons and rings. Now, as Voyager 2 moved beyond the heliosphere, it began collecting complementary data on plasma density, magnetic field strength, and galactic cosmic rays, allowing researchers to compare conditions at different interstellar locations. Together, the Voyagers act as dual sentinels, probing the galactic frontier and transmitting scientific gold back to Earth. Their findings are helping us understand the nature of the heliopause, the outer boundary where the solar wind is no longer strong enough to push against the interstellar medium. This region, once mysterious and undefined, is now being mapped and measured inch by inch, thanks to these two robotic explorers. Incredibly, even after over 45 years in space, both Voyagers continue to operate, despite dwindling power supplies and aging technology. NASA's engineers have had to make tough choices, turning off non-essential instruments one by one to conserve energy. Yet the core systems that monitor cosmic radiation, magnetic fields, and plasma waves remain active, providing invaluable data for humanity's understanding of the universe. The story of the Voyager probes is not just one of science and engineering. It is a story of perseverance, of vision, and of our species' eternal desire to reach beyond the known. These spacecraft have become cosmic time capsules, sailing into the void with Earth's message etched on the golden record, a greeting to any life forms that might one day encounter them. As Voyager 1 listens to the hum of the universe and Voyager 2 silently travels ever farther, we are reminded of the words of Carl Sagan, "Somewhere something incredible is waiting to be known." Stay with us as we continue to follow their journey beyond the stars. This revelation, that space is not the silent void we once imagined, has profound implications. For decades, interstellar space was presumed to be a vacuum of stillness, where silence reigns supreme. But Voyager 1's sensitive plasma wave instrument reveals something far more dynamic and alive. The interstellar medium is not a static backdrop. It is a living ocean of particles and waves, vibrating with the faint but persistent heartbeat of the galaxy. What makes this ether even more fascinating is its stability. It doesn't roar like a solar storm or flare unpredictably like a quasar. Instead, it maintains a narrow frequency range, about 300 MHz, like a whisper echoing endlessly through a cosmic canyon. This monotony, though subtle, is remarkably consistent. It implies that the density of interstellar plasma may be more uniform than previously believed, or at least not as chaotic as some models had once predicted. Even in the stillness, Voyager 1 detects gentle fluctuations, tiny shifts in pitch and intensity, like ripples spreading across the surface of a still lake. These nuances help scientists estimate the density of electrons in the plasma, and, more importantly, how that density changes as the spacecraft continues to push farther into the galaxy. But the significance of these findings goes beyond plasma physics. The very fact that we can now hear interstellar space reshapes our sensory relationship with the cosmos. It adds a new layer to our understanding: sound. Not sound in the traditional sense, for space is airless, but electromagnetic oscillations converted into audio by Voyager's instruments. This cosmic hum becomes a kind of auditory fingerprint of the universe, a melody played by the particles that once formed stars, planets, and perhaps life itself. This discovery has even begun to influence other areas of research. Astrophysicists are now considering how galactic magnetic fields, remnants of ancient supernovae, and interstellar turbulence contribute to the structure and music of this vast expanse. It hints at a galactic ecology where stars, gas clouds, and even black holes may all play a role in shaping the invisible symphony of the universe. And then there's the poetic beauty of it all. A spacecraft built by human hands, launched in 1977 with the computing power of a pocket calculator, now floating alone through the interstellar abyss. Glistening, still functioning, still responding, still transmitting data across billions of miles. It is a technological ghost ship, piloted by no one, guided only by the last flickers of power from its aging radioisotope generator, yet it continues to unveil the deep whispers of the universe. Voyager's instruments were never originally designed to function this far from home. They were meant to survive the planetary tour of the late 20th century, Jupiter, Saturn, and perhaps beyond. But these resilient systems have defied time and expectation, and now serve as humanity's oldest eyes and ears in deep space. In the years ahead, this cosmic hum will continue to play, and Voyager 1 will keep listening until its power wanes and silence finally falls. But even then, the data it has sent will remain, echoing in our databases and our dreams, a sonic imprint of the stars between stars. So as we contemplate these faint vibrations from the edge of the sun's domain, let us remember, space is not empty. It sings, and thanks to Voyager, we are finally beginning to hear its song. It appears that such moments of tranquility within the interstellar medium occur with far greater frequency than previously imagined. The universe, it seems, has a hidden, almost poetic rhythm, one that Voyager 1's sensitive sensors have now unveiled for the first time in human history. As we stand on the precipice of more profound cosmic discoveries, one fact remains constant: the unwavering journey of the Voyager probes. Their relentless quest for knowledge, spanning nearly 5 decades, is a testament to human curiosity and ingenuity. However, this incredible odyssey is not infinite. The Voyagers are expected to continue their scientific activities only until around 2025. By the 3030s, they will have ventured so far beyond our blue planet that communication with Earth will become impossible, the faint signals lost in the vastness of space. Yet, even as their voices fade into silence, their legacy will endure. Encapsulated in the iconic Voyager Golden Records, time capsules of humanity, the probes carry a message of our existence, destined to drift through the cosmos for hundreds of millions of years. These records, inscribed with sounds and images from Earth, stand as a beacon to any distant civilization that might encounter them, bearing witness to the achievements, hopes and dreams of humankind, long after our era has faded into history. Turning our gaze back closer to home, we cast our minds to a moment forever etched into the annals of human achievement. July 20th, 1969. It was on this historic day that 2 intrepid astronauts, Neil Armstrong and Buzz Aldrin, took humanity's first footsteps on a foreign celestial body, the Moon. Armstrong's iconic words, "That's one small step for man, one giant leap for mankind," resonated across the world, igniting a flame of wonder and possibility in the hearts of millions. In the wake of this momentous event, ambitious plans were laid out. Plans for numerous lunar landings and the ultimate goal of establishing a permanent human presence on the Moon. This era marked the dawn of a new frontier, where science, technology, and human spirit combined to push beyond the boundaries of Earth. The Apollo missions not only expanded our understanding of the lunar surface, but also laid the groundwork for future exploration, inspiring generations to dream bigger and reach further. As we reflect on these extraordinary voyages, from the silent cosmic hum captured by Voyager 1 in the distant interstellar medium to the footsteps left by humans on the lunar soil, one truth stands clear: exploration is woven into the fabric of our species. It is this insatiable desire to understand the unknown, to connect with the universe beyond our blue planet, that drives us forward. And now, as new missions prepare to revisit the Moon and venture even further, humanity once again stands at the threshold of discovery, ready to unlock the next chapter in our cosmic story. Presence on our satellite, however, the years have passed, and the last manned excursion to the Moon occurred nearly half a century ago. Yet the aspirations of several countries and space agencies remain undiminished. Their vision to return to the Moon and establish permanent lunar stations while harnessing the Moon's valuable resources continues to inspire innovation and exploration. This vision, however, is not without its formidable challenges. Establishing a sustainable human presence on the Moon requires vast resources: energy to power habitats and equipment, water for consumption and agriculture, and a reliable supply of breathable air. Among these challenges, one obstacle looms larger than the rest: the hostile lunar environment itself. The Moon's surface is marked by extremes that defy imagination. During the lunar daytime, temperatures can soar to nearly 250 degrees Fahrenheit, scorching everything in their path. In stark contrast, lunar nights plunge into bone-chilling cold, with temperatures plummeting to almost minus 275 degrees Fahrenheit. These extreme conditions pose a monumental challenge to human exploration and habitation, testing the limits of engineering and human endurance alike. Yet, hidden beneath the barren lunar surface, within the labyrinthine passages and caves formed by ancient lava flows, a potential solution may lie dormant. Recent probe images and data have hinted at the existence of these subterranean lunar realms. Vast networks of winding depressions and skylights, circular holes formed when cave ceilings collapsed. These skylights, with diameters ranging from about 50 to 500 feet, could very well serve as entrances to extensive underground cavities, potentially shielding future lunar settlers from the harsh surface extremes. To assess the viability of these lunar caves as potential habitats, scientists embarked on detailed missions to uncover their temperature profiles and environmental conditions. One such study focused on a skylight located near the lunar equator, a collapse hole that could provide a natural gateway to a subterranean refuge. Preliminary observations indicate that these caves offer remarkably stable temperatures, buffered from the searing heat of lunar days and the frigid cold of lunar nights, making them an ideal environment for human habitation. If successfully utilized, these underground lunar caves could provide shelter from cosmic radiation, micrometeorite impacts, and the relentless temperature fluctuations that characterize the lunar surface. Harnessing such natural havens could revolutionize how we approach lunar colonization, turning the Moon from a barren rock into a sustainable outpost for humanity. As we continue to explore these hidden lunar landscapes, the dream of establishing a permanent human foothold on the Moon edges closer to reality, an endeavor that could one day serve as the launching pad for humanity's journey deeper into the cosmos. Approximately 300 feet deep and 300 feet in diameter, the lunar skylight captured by NASA's Lunar Reconnaissance Orbiter, LRO, has become a focal point of scientific curiosity and hope. Equipped with a thermal camera, the LRO provided invaluable data that allowed scientists to delve deeper into understanding the thermal dynamics within these intriguing formations. Using this data, researchers constructed detailed physical models of heat conduction to reveal surprising insights about the lunar environment. Despite the searing temperatures on the lunar surface during the day, where sunlight heats the exposed rock to over 280 degrees Fahrenheit, the bottom of this vast pit registered temperatures influenced not only by direct solar radiation, but also by thermal radiation emitted from the cave walls. This heat retention was expected, given the rocky enclosure, but what was truly remarkable lay just beyond this harsh environment. Within the cave adjacent to the skylight, temperatures held steady at a comfortable and stable 63 degrees Fahrenheit, a stark contrast to the extreme fluctuations on the surface. This constancy highlights a critical principle. The larger and more enclosed the cave, the more stable and temperate the environment it can maintain. Such findings underscore the immense potential of lunar caves as natural shelters for future human explorers. Beyond simply offering room temperatures comfortable enough for habitation, these subterranean havens provide critical protection against two of the Moon's greatest hazards: meteorite impacts and cosmic radiation, both of which pose severe risks to life and technology on the surface. However, before humanity can fully embrace this vision of lunar colonization beneath the surface, these caves require comprehensive investigation. Future missions must validate their structural integrity, assess environmental conditions, and explore the feasibility of supporting long-term human presence. If successful, these lunar caves could become the cornerstone of humanity's next giant leap in space exploration. The prospect of humanity's future lunar outposts nestled within air-conditioned lunar caves is a tantalizing vision, one that could soon become a reality. These natural shelters promise to shield us from the Moon's extreme temperatures, deadly cosmic radiation, and meteorite impacts, creating safe havens where astronauts might live and work for extended periods. As we dream of this next chapter in lunar exploration, our eyes simultaneously turn toward the farthest reaches of the cosmos. At the frontier of modern astronomy, the James Webb Space Telescope stands as a marvel of human ingenuity. Launched to unlock the deepest secrets of our universe, Webb's mission is to peer back in time, capturing the faint light of the earliest galaxies and luminous objects that sparked the cosmos into brilliance shortly after the Big Bang. Though Webb's scientific journey has only just begun, it has already transformed our understanding of the universe's infancy. Among Webb's most extraordinary discoveries is the detection of one of the oldest galaxies ever observed, scientifically known as Glass Z13. This ancient congregation of stars and cosmic matter, formed a mere 300 to 400 million years after the Big Bang, making it an astonishing 30 million years older than the previous record holder, HD1. This groundbreaking finding not only underscores Webb's unparalleled observational power, but also heralds a new era in our quest to unravel the mysteries of cosmic origins. As we stand on the precipice of ever greater cosmic discoveries, we invite you, our fellow explorers, to share your thoughts on the enigmatic Voyager 1 detected in interstellar space, as well as the tantalizing prospects of establishing lunar bases within the Moon's caves. Your insights and curiosity continue to be an invaluable part of our shared cosmic exploration journey. Thank you for joining us on this celestial odyssey. Rest assured, we will continue to bring you the wonders of the universe as they unfold. Stay tuned for more awe-inspiring revelations from the cosmos, because the story of space is far from over, and together we're just getting started.